this is the saddle point, so it means that the value of minimax and the value of maximum are equal. So in this case, it means that this is the best or the strategy for both of them in this case. So they cannot getting the improve of any payoff outcome anymore, even though they change the strategy or they can know the strategy of others company, right? And we also have like a, so in this case you can see, okay, this is an explanation. Company A, right, choose strategy A1, right, or the cash rebate, and can expect again at least, right, 1% or one sale per week, let's say, and company B choose strategy B3 or 0% loan, and can expect loss no more than one equal sale per week. What happens if we have no saddle points, or what is mean that maximum not equal to the minimax? So in this case, it is not a pure strategy. We call a mixed strategy. A mixed strategy is this means that each player can employ more than one strategy, and the way that we calculate, we try to find the optimal, right, between the strategy that each player select, right, and we try to comparing, right, the value from all of their strategy. For example, in this case, we have player A and B. Once again, player A has two strategies, A1 and A2. Player B has two strategies as well, B1 and B2. And in this case, based on the maximum, right, you can see that player A choose have like 5 as a maximum, but the player B, right, they choose have like the minimax value at 8, right, and you can see that in this case 5 and 8 not equal, so we call the mixed strategy. So the mixed strategy. So how can we find the solution? So let's say that we let P be the property of player A, select strategy A1. And for sure, the rest of the property is going to be the property of player A, select strategy A2. Right? So A1, we assume that we have property P, A2 then is equal to 1 minus P. Right? So if we try to consider that the case player B select strategy B1, what happens? If the player B select strategy B1, right? We can expect, right, the expected, right, value of the payoff, right, equal to 4 of A1, right, multiplied with property P, plus 11 of A2 multiplied with property 1 minus P. So that's why we have 4P plus 11 multiplied with 1 minus P. But on the other hand, if player B select strategy B2, this case, so player A can expect, right, the payoff equal to 8 multiplied with probability P plus 5 multiplied with probability 1 minus P, or this one. So for the mixed strategy, we let them both try to find the optimal one of the probability. So we let both of these cases equally. So then we have this equation 4P plus 11 of 1 minus P equal to the 8P plus 5 of multiplied with 1 minus P. We solve for P. In this case, P equal to 0.6, which means 1 minus P equal to 0.4. Or we can say that player A choose select strategy A1 with 0.6 probability and strategy A2 with 0.4 probability strategy. Select strategy A2 with probability 0.4. Okay. So this is the way that we call the mixed strategy. On the other hand, we can solve the same concept with player B or company B. So if we let Q to be the property of player B select B1, 1 minus Q to be the property of player B select B2. If player A, once again, in this case, if player A select strategy A1, what happens to B? player B can expect the payoff, right, equal to 4P, 4Q plus 8 multiplied with 1 minus Q. And if player A select A2, player B can expect, right, payoff equal to, 11Q plus 5 multiplied with 1 minus Q. And then we let these two equal to solve for Q. We have Q equal to 0.3, so it means 1 minute Q is going to be equal to 0.7. So in this case, it means that player B should select strategy B1 with 0.3 probability and select strategy B2 with 0.7 probability. So based on this, what do we have here? So the value of the game is different from the pure strategy, right? That we have the starting point value of game is just 1, right? One game 1. But in this case, it is mixed strategy. So if we substitute, right, for example, the probability, right, 0.6 and 0.4 for player B, and 0.3 and 0.72 and from player B, to the equation of expected payoff that they can get. So you can see that they're going to have the value of gain equal to 0.6, 0.8 equal. And what happens if we have, more than, let's say that in this case we have 2 persons, so some game, but we have no optimal pure strategy, right? Because of, you can see here we have player A, 3 strategy, A1, A2, and A3, and player B, B1, B2, and B3. Maximin, right, is 0, right? But minimax is 3, both are not equal. But we cannot using the same method as the previous one, because based on previous one, right, you have just, in this case, you have just 2 strategy, right? You have just 2 strategy from this example. So I mean, each one you get it probably equal to P, another one is 1 minus P. But in this case, for this one, you can solve for the same method, because we have 3 strategy, let's say. If you let property for A1 equal to P, how about property of A2 and A3? Right? We cannot write, But sometimes, right, for the game theory, we can delete some strategy, right, in order to reduce the, the matrix of payoff. For example, in this case, you can see that if we consider between, strategy A1 and A3, what happened? Based on strategy A1 and A3, in every cases of strategy of player B, you can see that strategy A1 always win when comparing to strategy A3. For example, if B select B1 strategy and player A select A1 strategy, they can get 6, right? But A3 get 3. This one more than this one also more than this one also more than this one. So strategy A1, right, is dominant strategy A3. So in this case, no matter what, player B using which strategy A1 always wins strategy A3. So in this case, you can, eliminate strategy A3. So when you do this, right, you can eliminate strategy A3 and you can set rename to be A1 and A2. Also, for the case of player B as well, if you consider, in this case, you can see if you consider between strategy B1 and B2, strategy B1 dominate B2, because no matter what player A using strategy A1 or A2, strategy B1 always win B2, because B1, in this case, if player A use A1 and B use B1, you get 6, but if B use B2, you get 5, so this one is win, this one is less than 6. And for player A, select strategy A2 as well. If you select B1, you get 1. If you select B2, you get 0. So this one is higher than this. So B1 dominate B2. So you can eliminate B2. So then you now have the matrix that have, the size of 2 by 2. Once again, you can apply the concept as usual, that given the property for A1 to be P, A2 to be 1 minus P, and giving the property of B1 to be Q, and property of B3 in this case to be 1 minus Q, so you can solve just like before. But if you cannot eliminate, right, row or column or each strategy, so you need another method that beyond our class. Okay. So now what I have for you now, and I want you to understand. Firstly, we talk about utility. The keyword of utility is that money only are not always the way of good enough to help you make the decision, because each people you have the different right attitude toward the risk and the payoff. So in some cases that you have very difference between the highest payoff and lowest payoff, or the problem of profit and loss, you might think about integrated the attitude toward the risk or money from utility, right, to the decision making concept. So that's why we try to calculate the utility value and using the concept of expected utility value to be the way that select the alternative. Then we talk about the game theory. So the game theory is now that we introduced is about the introduction. We talk about two-person zero-sum game. So it means that we have just two players in the same market or in the same industry, let's say. So if one gain, another one's going to lose. So the benefit of game theory is that you can use it to develop and think about the strategy that you try to win with other company. Right? Let's say in this case, in my example, we talk about getting market share, right, from other company, right? So then we using the concept of maximin and minimax, because in this case, for example, you have dealer A and B, and in this case of the dealer A, right, you try to find a strategy that can get market share from B. So the concept that suitable is maximin, because if you apply maximin in this case, right, it belongs to strategy A1. It means that no matter what, company B or dealership B choose what strategy, B1, B2, or B3. If your company, dealership A, you select strategy A1, you guarantee 1%, right, of market share gain from B. On the other hand, for the same concept, if we look at the side of dealership B, right, we can apply the concept of minimax, because in this case, if we apply the concept of minimax, we select company B and select strategy B3. It means that no matter what, dealership A choosing which strategy A1, A2, or A3 to getting the market share from you. If you apply strategy B3, you can guarantee loss just only maximum 1% of the market share, right? And in this case, one more that we talk after the break is that you can see that maximin and minimax both have the same equal value, in this case equal to 1. So this means is we call the saddle point that is made up has the what we call PO strategy. So it means that in this case, dealership A should select A1, B should select B3, right? And they can guarantee 1% gain or 1% maximum loss. And this is the best payoff that they can get. No matter what that they can know another strategy from another company, or they try to change their strategy, they cannot getting the benefit more than this. Right? But we talk in another case that if we have, let's say, this example, when you apply the same concept, maximin and minimax, but the value of maximin and minimax is not equal. In this case, it's not provide you with the saddle point or the PO strategy. So on the other hand, it called that we need to develop what we call mixed strategy. So in the case of finding the mixed strategy, it means that we try to find the probability of that company or that player going to select each strategy. So in this case, we then develop using the concept of expected value. but the probability we using is P and 1 minus P for one side. Another side we just assume to be Q and 1 minus Q, let's say. And just said that we try to make the calculation of finding P or Q. Right? That would be the property that suitable for, in this case, player A and player B to choose select. Because with this calculation, when you try to calculate the value of the game, you're going to have the same value right here. Right? So this is what we call. And lastly, we talk about in the case that you have more than two strategies, so you cannot using the same concept that finding probability P or Q. So then you might think further to see that is there any strategy that dominate others. If you have, you just eliminate the weak strategy and keep the dominant one. So then you can reduce the size of the matrix, and then you can apply the same concept, right, to calculate the property of each strategy. So this is the game theory. Okay. Do we have? We're gonna have another one that I think is not that take time much, because the real one is very difficult, but we just study very introduction. We're gonna talk about the Markov process. Okay. So the last topic for our course, right, because this coming Thursday we have a guest speaker. I will come to introduce the guest speaker, okay? And I will go have buffet. So I will leave you with the guest speaker. It's my time. I will come to the class, okay? And just ready first for introduce the guest, and bye-bye. I have the meeting with other group of students to have buffet. Okay, but this is the last topic of us. Okay, I just very introduction. Okay, I forgot that we're gonna not select this, study this one. This is because the concept of Markov processes, you need to have the background of matrix, right? So some of you may not have the background of matrix study, because if you study in art or graduate from art or fine art or whatever, so you might curious that, so how can we solve for the matrix, right? So so then I'm cut off some topic, because I just want you to know. So what is a Markov? So Markov process, we talk about the study of evolution of the system for over the repeated trial, right, for the time periods. So in the easier word, it means that for the business, we can apply the Markov processes a lot in the marketing strategy. For example, using the Markov to study the case that the consumer or the customer gonna switch the brand. Let's say that you have the choice of service provider for your cell phone. You have AS, DTAC, and True, right? So we can use the Markov process to estimate that, okay, for next month, right? Now you use DTAC. For next month, let's say, or next year, for which service provider they're gonna choose. And how about the next 2 years? How about the next 3 years? Right? So the way that we choose using the Markov process, we can use to study the behavior of the consumer to switch, right, or select the brand, or you can use it to study about the strategy. So for sure that it's just involved about the probabilities, right? So this is the application. You can using the Markov to indicate that you try to study the promotion of manager to various positions within the organization. So this person is going to go to manager or just assistant manager or going to the assistant vice president? Okay, we can estimate. The immigration of people in and out of that regions, right? The location of the student in the college, right? We can using the Markov to study. Right? So in business, we're using a lot for the consumer purchasing or switching the bank. So that's why is the first period they choose brand A. How about the next period they may choose another brand. So we're going to study that, like the evolution of the system, something like that. Or using the Markov to study the functional of operation of the machine. That's machine to the breakdown or full function to operate for the next period. We can study as well. So let's see this example. Right? Suppose that we are interested in analyzing the market share and customer loyalty of the company called Murphy and Ashley. We have Murphy and Ashley supermarket. These two are the two grocery stores in the small town. So we're focusing on the sequence of shopping trip of one customer. And assume that the customer makes one shopping trip each week to either Murphy or Ashley, but not both. Okay, so this is assumption, right? For each week, the customer makes just only one shopping trip, right, at Murphy or Ashley only, not both of them. Right? So what do we have here? Let's say that we have the weekly period, or we call shopping trip, right? Is sometimes we call the trial of the process. In this case, it's called trial of the process. So it means that each trial of the process. So the customer, we're gonna stop at Murphy or Ashley only, right? So the particular store that the customer select, right? In that week, we refer to the state of the system, right? In that period. Right? So in this case, since the customer has only two choices, that shopping out to just two shopping alternative for each trial, that means shopping at Murphy or Ashley. So in the overall system right now, if we would like to develop the Markov model to study, we have just two steps. The first step, or we call step 1, is the customer shop at Murphy. And step 2 is the customer shop at Ashley. Okay? And what happened next? Just like the simulation, Monte Carlo simulation, we have the historical data that you can try to collect the data for when a shopper over the 10 weeks period before, and you review the data, you support that, you find that the customer who stop at the Murphy in a given week have 90%, but 10% is gonna shop at Ashley. So in this case, it means that the customer who shop at Murphy, right? For the next week, 90% still shop at Murphy, and 10% shop at Ashley. On the other hand, based on your information as well, on your data as well, you analyze it. You find out that, okay, with the same data, the customer who has shopped at Ashley first, for the next week, 80% they still shop at Ashley, and 20% they can shop at Murphy. Okay? So in this case, right, this probability we call transition probabilities, or the probability that provide the chain of the state of the system from one period to another period. Right? Let's say from period n to period n plus 1, something like that. And when we try to write down the transition probabilities, we can use it represented by in the metric form we call the transition metric. For example, in this case, okay, let me explain a little bit the Markov processes that we studied in our class. We studied just very introduction. We studied the case of stationary transition probabilities. So it means that we have the limit number of states. In this case, we have just step 1, step 2. Remember, Murphy or Ashley, shopping at Murphy or shopping at Ashley, and the transition probability we assume that is constant, right, from state to another state. So it means that it will not change anymore. And the progress of being in the particular state, let's say the next state, let's say the period n plus 1. It depends on the current state, period n, right? Multiply with the property that we call the transition probability. So for example, if you look at the table up there, this is the transition probability from the information that I just mentioned here. You can see what happened here. We know that if the current week customer shop at Murphy, for the next week, based on the information that we have, we estimate that 90% of the customer who shop at the current week at Murphy, we're going to have 90% shop at Murphy, and another 10% going to change, right, the supermarket to shop at Ashley. On the other hand, based on the same data, we can analyze that the customer who shop at Ashley this week, for next week, they have 20% chance going to change to shop at Murphy, and 80% just still stay shop at Ashley. So this is the transition probability. So if I rewrite in the form of matrix, right, we have 2 by 2 matrix, right? These 2 horizontal and these 2 columns, just like this. So I'm using the general form, P11, P12, P21, P22. The first digit represented for the horizontal or the row, and the second digit is for the vertical or the columns. Right? This is the property for first row, first column, second row, first column, something like that. So in this case, if I use this, right, you write this form, the following matrix, I'm going to have the matrix of 0.9, 0.1, 0.2, 0.8. This is called the transition probability. And the system that we study in our class, we assume that this one constant and not change, right? From state to state, still using equal this probability, will not change anymore. In this case, what happens next? If we try to rewrite using the division node here, you can see this is the case of this figure show you in the case of the current week customer shop at Murphy. We know right that 90% for the next week, the customer gonna shop at Murphy, and 10% at Ashley, right? So probably is 0.9, 0.1. What happened to the next? Transition is still the same, right? So from this week to another week, so it means they have 90% still shop at Murphy and 10% to Ashley. So in this case, you can see that if we talk about the current period, this one is the notation of probability, nothing much, not pi, is probability. Probability of state 1. This is the 2 is the second state. The number in the parentheses is the period. For example, if period 0 or the current period, the probability is going to be, this case on, I would say this one for the customer that currently shop at Murphy. So if currently this customer shop at Murphy, the period is 0 period, right? So the probability of shopping at state 1 or at Murphy will be 1. And the probability of shopping at state 2 or Ashley as 2. But for the next period, right, we know that 90 and 10%, right? 90% is going to shop at Murphy and 10% going to shop at Ashley. How about the next period? We have 83 and 0.17. That's come from this one, right? We're going to talk about this period. This is the current period, right? This is the current period, right? Right, Bob at Murphy equal to 1. This is the period 1, right? Bob at Murphy 0.9, actually 0.1. How about this period? If we consider about probability of shop at Murphy, we have this one and this one. So then you combine together, we can have 0.83. And the probability of shopping at Ashley, you have 0.09 and 0.08. You combine, you can have 0.17. So that's why you have this. You have this one. 0.17. Okay? The same if you try to find for another period, a period. In this case as well, if we do the same way, but I change at the current period to be the customer shop at Ashley first. So you're gonna have the property of state 1 at period 0 for state 1 of Murphy 0 and naturally to be 1. We can solve using the same concept. So what happened that we can see here from these two tables? You can say that when you have period more and more and more and more and more and more, the property is same constant. At first you can say it's 0.9, 0.1, right? When you do more and more period, it changes to 0.8, 0.78, 0.74, 0.72, 0.7, 0.69, 68, 68, 68, 67. So it's changed a little bit. It's quite come to the steady, right? So in this case, what do we have here? This means that the probability that when we have more and more period to calculate, right? The probability seems coming to the steady state. So we call the steady, they call the steady state. So what we try to solve in this case, since I'm saying that you can see this one is 0.69, 0.3, 0.68, 0.31, 0.68, 0.32, 0.67, 0.32. So it's quite very similar. So if we try to find the property of to be the steady state, right? So you can solve, right? I'm gonna skip these two slides because I'm gonna show you the example is more clearly, right? For example, let's say that I have this property, right? Let's say I call pi 1. Pi 1 is be the property of finally it's going to visit at Murphy, and pi 2 is going to be Ashby. Remember, this is the transition probability, right? Okay. So if we have this form, what happened? This comes from the just let's say this is the state. Assume this is the state n. This is the state n plus 1. So what happened? As I show you this slide, when state is increased, more period when we have state. The explanation, the state I mean the period. Okay, the period when you create, you have increase. You can see that the value is very close together. So it's quite that from here, look at this. From here, you change to here. Actually, you're using this one multiplied with the transition probability and you're going to get another one, right? And the value is very close, okay? So by using that concept, it's just like we call that, okay, state 1 and 2, when you multiply with the transition probability, you can get the same value, okay? And don't forget that the property of these two states need to combine equal to 1 as well. Okay? So when you solve for this, using the concept of the matrix, what you're gonna do here? So you're using this one multiplied with this one, right? Right? And what next? We have to teach the matrix for you. Okay. You're gonna have this one multiplied with this one plus this one multiplied with this one. We say if you have in this head, this is the 1 by 2 matrix. This is a 2 by 2 matrix. When you multiply together, you're gonna have matrix that have the 1 by 2 matrix. Okay? Did you remember matrix? You have 1 by 2. Remember 1 by 2? 1 row, 2 columns. And then you operate to multiply with matrix 2 by 2, 2 rows and 2 columns. Finally, the result, you still have the matrix 1 by 2 matrix. Because you delete this one, you can have this and this. Okay. So that's why, in this case, you this one multiply with this one plus this one multiply with this one. You can have 0.9, 1 plus 0.2, 2. And another one, you using this one multiply with this one plus this one multiply with this one. You have 0.1, 1 plus 0.8, 2. And probability when they combine together is going to be equal to 1. So we solve for pi 1, pi 2 here. So finally we have 0.667 and 0.323. So it means that if we have 1,000 customers in the system, the model tells us that in long run, in the future, with the steady state probability, pi 1 is 0.667 and pi 2 is 0.333. 667 customer will be at monomorphic and 333 will be at ASHRAE. Okay, so furthermore, if we try to changing some strategy to increase about the property that the customer gonna stop at ASHRAE, right, more than the previous one. Because the previous one, if you look at this probability, you can see if the customer current week shop at Murphy, for the next week 90% they still go to Murphy and 10% go to ASHRAE. Right now we talk in the case that ASHRAE supermarket, they try to develop the strategy to increase their sale. They're using their marketing in order to make the customer who currently shop at Murphy and for the next week have the probability increase from 10% to ASHRAE to be 15%. So in this case, we're going to have this case change from 0.1 to 0.15. So the property now change, right? The previous one, this one is 0.9, this one is 0.1. But now we assume that the ASHRAE supermarket, they develop the campaign using the strategy that try to increase, right, the property that select, make the customer who buying at Murphy for this current week, but for next week increasing to have by chance to shopping at ASHRAE to be 15%. So what happened here, if we try to solve for the steady state probability, same concept, right? So we're using the property of saying you're gonna have something like this. Pi 1, pi 2, right? You can have 0.85, 0.2, right? 0.15, 0.2 equal to something like this, right? And you cannot see. I'm gonna change, sorry. Change to, so what color do you prefer? I have no idea. How can I change the color? I have no idea. I don't know. So can you see that? Okay. So just like you have pi 1, pi 2 here, right? You multiply with 0.85, 0.15, right? And this one 0.2, right? Yeah, 0.2 and 0.8 equal to probably doing the same way, just like this. Doing the same way. So do the same. We do the same. Right? But since we change the probability in this case, so when we do this, right, and we're gonna have this one. And don't forget the property of pi 1, pi 2, since we have just only two steps. The combination needs to be equal to 1. We have another one to solve, right? And then when you try to solve, you're getting the property of pi 1 equal to 0.57, another one is 0.43. So which means that if you have the total market of 6,000 customers per week, when you using the new strategy, promotional strategy, it can make the customer increasing from 2,000 to 2,580. This one come from what? This one come from the previous one that you calculate. The previous one you can see the property for ASHRAE is 0.333, right? So then when you're using this one, it comes from 333 or 1/3 of 6,000. But 2,580 come from what? Come from the property that you change after you change strategy is 0.43. So this one comes from 0.43 multiplied with 6,000. So the property increase, so you can see that you can expect more customer. When you have more customer, and let's say that you think that you can gain the profit per customer is $10. So in this case, you can expect more profit equal to $5,800. So then you can compare with the cost of doing the promotional strategy. If the cost of promotional strategy that you're going to use is less than 5,800, it means that if you were actually, you should perform this strategy because it's worth to gain, right? Their benefit, something like that. And what next? We have another example, right? In this case, we do have that Henry is a salesman, right? So call once a week to speak with the store buying agent, Shirley, right? But Shirley, if Shirley does not accept the call from Henry this week, the property she will do the same next week is 0.35. On the other hand, if she accepts the Henry call this week, the property that she will not do so next week is 0.2. So this is the transition matrix, right? This week's call, right? If now, right, the what's the name? Cherry, right? Cherry. If Cherry now refuse, right? Next week, she can refuse to get the call. She can refuse is 0.35 or 35%, right? But if name Henry, right? Henry and Cherry, okay. If this week call, right, and Cherry refuse the call, the property that next week she can refuse is 0.35 and accept the call 0.65. On the other hand, if this week Cherry accept the call from Henry, so the next week there's a probability of 0.2 or 20% that she's gonna refuse the call, and probably that she's gonna accept the call 80% or 0.8. So this is again is a transition matrix from change state to another state. And if we have this kind of problem, question, let's say, question one, if I want to know that how many times per year that Henry expect to talk to Cherry, right? So because don't forget that Cherry have two choices, right? Pick up phone or to accept or refuse, right? The answer is that we just try to find a long run or steady state probability, and then we multiply with 52 weeks because the question asks for a year, right, per year. So here we do the same. So this is the state that probably gonna have. Pi 1 is the probability of long run of refuse the call. Pi 2 is like accept the call. Again, we do this form, right? This one is a transition probability, right? Or we getting from this, right? So we try to solve again the same concept, right? Try to find a steady state probability. So in this case, after we do it, right? And don't forget this relationship, these two probability needs to combine equal to 1. We solve for pi 1, pi 2, and what do we have here? We have pi 1 is 0.23529, pi 2 is 0.36471, right? Then since we try to find the property of the long run accepted call, so accepted call is the property of pi 2. So then we use 0.3647 and 1 multiplied with 52 weeks. So we have roughly that round off to be 40, around 40 for 52 weeks. That when the Henry call Cherry and Cherry is gonna accept the call is around 40 for 52 weeks. Okay, and what happens If we have another questions that what is the property that Shirley will accept Henry next to call if she does not accept this call this week? Don't forget that you can solve using the same concept, right, of Murphy and Ashby example, remember? This is show the case that this current period, right, Shirley refused to accept the call from Henry. So for the next week, there is 35% that she still refused to get the call, and 65% to accept the call from Henry. So then from this, again, 35% to refuse, 65% to accept, right? But for this situation now it is a case that current state is accept the call, right? When you have the state of accept the call, remember that now you're gonna accept the call. 20% to refuse and 80% to accept. So that's why you change here, right? Now you accept 20% to refuse and 80% to accept. So this is the probability for these 2 weeks, or this the probability of each of them. And since they asked us about the probability that she will accept Henry in the next 2 call, if she doesn't accept in the call this week, so doesn't accept, it means starting with refuse, so this is the next 2 weeks. So this is the probability that they're gonna accept for the next 2 calls. Accept probability is 0.65 multiplied with 0.8, you can have 0.52. Right? The same, if we have the find the probability of surely accepting one of Henry's next 2 calls, if she accepts his call this week, so we can solve it, right? This one didn't show you yet, so we can solve. For example, if we start with accept, what we see for the property, we have x. Let's say we have accept, right? We have to refuse and accept. We're gonna have like the probability for this one, accept to refuse 20% and 80% to accept. This 20%. This is at 80%. What next from this? We're going to have refuse and accept. Starting with the refuse to refuse 0.35, another one is 0.65. This one 0.35, this one 0.65. How about this one? You go to refuse and accept. This one 0.20, this one 0.8. Okay, so if you want to find the property that actually one of the next 2 calls being accept, if this week call is accept, right, you can using the property of accept next week and refuse the following week, and refuse next week and accept for the following weeks. So that's why you have let's see there. One of the next 2 call being accept. Okay. One of the next call being accept. Okay, this one and this one. So this one you're gonna have 0.65 multiplied with 0.2. You have 0.13. This one you're gonna have 0.8 multiplied with 0.8. No, 0.8 multiplied with 0.8. Let's see. One accept. Next week will be except starting with except, right? Probably all except next week, review following week. This one is going to be going to be this one. So you have point 2, point 8, you have point 16. So then you combine this together. And you're going to have point 13 plus point 16. Because we start with except, but the next weeks, right, we're going to find that the property that going to accept, right, one of the next two calls. So if we select this one, right, the next two call we have one accept. This is this one. The next two call we have only one select accept. Not this one. We need to show this one. Okay. So we're gonna have point 2 multiplied by point 8 and point 65 multiplied by point 2, which means equal to point 13, point 16 plus together we have point 29. So this is the answer for that. And finally, I want to go further than this. We have another property that we call absorbing state. This is the case that the property from one state to another one will be equal to 1. So if this one, or if this case happens, it means that the state that the current one move to the next state, and the next state we have the property equal to 1, right? You will not change anymore. You will stay for that state forever, right? So it's beyond, right, our class. Okay, so we are not study this one, so I've just mentioned, so based on the Markov that I told you today, at least I want you to understand about the transition probabilities, understand about the long run. That if you want to calculate for the long run, so you can use this concept, right? The current state multiplied with transition probability equal to the next state, but the next state is have the same value with the current state. And then once you can solve for the long run probability, then you can estimate, right, some benefit from the strategy, or you can estimate what you want to know, right, from the next state or the next two states, or what period that change of the behavior of the change of the player in the state to another state. Right? That's all for this. Okay, so just make sure that you understand the example in the slide. Right? Okay, so any question for this one? No, because you don't understand. It's not that easy, right? It is very beginning. So if we study the full version, I studied these Markov processes when I studied PhD. It's just one course and not that basic like this. We need to write the program, and then it's quite tough course. One of difficult course that I took when I studied PhD. So, but we are not go to that level. So just want to understand the basic. So now we talk about changing state to another state. When we change from state to another state, we need the transition probability. When you change more and more and more period of the state, you can have the steady state probability, right? And with that steady state probability, you can analyze further for the benefits or the behavior or the some set benefit from changing the strategy and so on. Okay, so that's all for this. Right? Let's talk about the contents of our course once more. All the information that we're going to use for the exam is stopped by this class. For the guest speaker, this might be one question for sure. I know the answer because I invite the guest to teach you, but I'm gonna have buffet. So maybe one bonus question from the guest speaker. Right? It's not that the calculation anymore, but maybe about the knowledge or the thing that you might tell us that you can, what you gain from her or what the thing that you can apply to the business problem, something like that. Okay, so I will ask you, not the guest. Okay, so you need to come to the class and understand what is the information that she's discussed and provide to you. Okay, and I will ask you as a bonus question, what is the the benefit or the gains that you're getting from this guest speaker? So this is one bonus question. But for the exam, the topic that we're going to cover will stop until this week, this class. Okay, so probably we have what is that? QE, right? Simulation, digital analysis, and game theory and backhaul. So 5 topics. I don't know yet because I'm not launched the exam yet, but I will tell you when we have the project presentation. Okay, that week. Sure, tell you about the detail for the exam that we need to prepare. And we still have like the open book of note as usual. Okay, using the calculators. Make sure that you have the right one because we have the queuing. Remember a lot of power 3, power 4, something. And that's all. Okay, so please present the case study. Okay.